welcome back to the last lecture in Basis and Practice in Programming. In this lecture, we are going to have our last topic for this course. It's about dynamic memory allocation. And in this lecture, we will have the outlines as follows. So we will explain the dynamic memory allocations, how we can allocate memory for our software dynamically, and this memory will go to a specific area in the memory. We call it the heap area. And then we will talk about how we can, and this is very important actually, for allocate storage. For example, if we have data and we would like to save this data to our memory, to the computer memory, but we don't know in advance how much this data. So we can decide the size we need for saving this data dynamically at the time when we are running the software. So we will reserve the memory to store our data at the time when the software is running. So this is very important here for design the exact or consume the exact memory of your computer without reserve this memory in advance when the software is not running, and we don't know if this memory will be used or not, will not be used. So for this reason, especially for kind of like arrays or structures or strings, which we don't know in advance before we run the software, and we want to reserve exact memory size for those arrays or strings or structure at the time when we run the software, and we know exactly how much the amount of data we want to save to the memory. Okay, so for this one, we will use something, we call it some function inside the library of stdlib. And in this library, there are several functions. One of them to reserve dynamic memory. One of them is malloc or memory allocation. Okay, so this memory allocation is a very simple function. And here's an example how this function is working. So you will create a pointer, and this pointer will point to the area in the memory where you are reserving this dynamic storage. Okay, so in your computer, when the software is running, you will create a pointer. Okay, and this pointer is this one, the PTR, and then you will run this function. This function you tell this function the size of memory you want to reserve to put your data inside. So you will say, for example, I want to reserve 5 blocks or 5 size 5 of integer. So the integer is 4 byte. 4 byte times 5, that means 20 bytes. That means I want to reserve in the memory 20 bytes. Okay, and those 20 bytes in the memory, I will use them to save some data. Okay, so this one is the malloc job. So the malloc job will generate for you, you will tell what is the size you want to save, you put number here. So this number is number of bytes you want to reserve in the memory. And then this malloc will generate some pointer. So you need to, usually malloc generate pointer, and that pointer type is void pointer. But I don't want void pointer. For example, if I'm reserving storage for integers, in this case, I will convert it to integer pointer. So that means there is a integer pointer point to this area, and it will handle numbers. It will store numbers. Okay. If I want to save in the memory, for example, floats, in this case, I will say this one is a float. Okay. That means I'm storing 5 floats, and those floats will be handled by pointer of type float. Okay. So this is how you can save dynamic memory in your computer, and this dynamic memory you will use it to save some data. Okay. So let's see some example here. In this example, which I will show you in Visual Studio, in this example here, we will have, for example, this is just one of applications of malloc or dynamic memory storage. So in this case, I will say, for example, this one, as you know, we learned this one before. This is like a string. We can define a string this way. So character pointer line. This is a string, okay? And then we can assign to this string whatever we want, okay? So here is also another string. If you see this one, character, and this is the name of the string, okay? And then you will assign this string here, okay? Evaluate the string. So that you create a pointer of character, and that pointer of character is pointing to the beginning of this string, okay? So here I define string, but I didn't give any value for this string because I don't give like what are inside this string or nothing. So I just say there is a string, and this the name of this string point to this string, it point by the pointer line, okay? And then after that I will ask the user how long is your line or how long is your string. So the user will say, okay, my string, maybe at the time when he run the software, he say, okay, my string will be, for example, 80 characters. And then what you say, okay, 80 characters, then I will reserve for you, okay, I will reserve for you here storage, and this storage equal what? This storage equal number of lines you reserve. You want a number of lines, that means this one, line len, that means number of characters you want, number of characters, and this one, how long is your line? How long, that means how many characters inside your line or in your string. So I put this one is the value inserted by the user. So the user insert this value by the keyboard. He say, okay, my string will be, for example, 10 characters. So you say, okay, here is 10 characters times size of character. Size of character is 1 byte. So that means reserve in the memory 10 bytes, and those 10 bytes will be for this string, for a string line, okay, for this string, okay. So this string now, so this pointer is pointing now to a string of 10 character. Then after that, I will ask the user, please, okay, insert the string. So the user insert the string, and then I will print this string, okay. So this is how you can do this one. Another example, if you see here, for example, here is a string, some string equals something, okay. This is a string, okay. And then after that, I would like to copy this one to this string, okay. So before I copy this one to here, I need to reserve some size for this string, because this string has no size at all, okay. So what I will do, I will say, okay, this malloc, I will say, okay, reserve memory, and this memory equal what? Is equal number of characters. You know, this one we studied last time, string length. So we will calculate the string length of this one, the some string, plus 1. This one plus 1 for the null character, okay? So I will say reserve in the memory the size of this string plus null character, and then after that I'll say, okay, use the string copy, which we learned last time. String copy from some string to this one, to this new string, okay. And then here I just evidence, I print for you copy to show you that copy is already got the value of this string. How are you? Okay, so let's run this software, or the first one together. So I will go to Visual Studio, and here is it. Okay, so in here I will say, okay, let me remove this one. Okay, so I will say here, ask the user, how long is your line, or how long is your string? He will say decide how long, and then based on his decision, I will reserve memory for this string, reserve memory. Then after I reserve memory, I start fill inside this memory, and then print this memory, okay? The other one here, I say, okay, I have a string here, but I have another string here. This string has no size. I don't know how much the size of this string. So I will say, okay, create a new memory storage, allocate at the runtime, allocate memory, and this memory will be the size of the other string. Why? Because I want to copy the contents of this one to copy. So I will save here, I will create the size. This is number. So this one will tell me the size, how many characters in the some string, plus 1, this one for null character, and then it will be the size of copy. Then after that, I copy from string, some string to copy, and then I print copy. So let's see this one together, this software, starting from here. So here is it. How long your line? I will say, okay, I want line with 15 characters, okay? So I want to reserve memory with 15 characters. So, okay, now when you click enter, it's reserving 15 characters. Then after that, he's waiting me now to get some text. So I'll say, this is a dynamic string, for example. Okay, so we will do this one. Then after that, it will print this one in the screen. Now, there is error. Why there is an error? Because I reserved 15, and now I am sending data more than 15 characters. This is wrong. Okay, so this is why software crash. Okay, so this is why we need to decide the correct, at runtime, we need to decide the correct number here for the string. Okay, so for this one, crash, the software crash here. So how to make this one not crash? I will put little bit bigger number. So I will say here, for example, how long is your string? I will say this one 50 characters. Click enter. Now this is fun. Okay, or this is a dynamic string. I think this one is less than 50 character. So click enter, no crash at all. You see, software continue, and then he print for you, the software print for you what is inside line here. And then after that, also reserve some memory for copy, and then copy some string to copy, and then put this copy. Okay, so here is it. This is the copy contents. Okay, so this is working fine to reserve. So if you reserve the correct number, the size of the string, in this case, it will not crash. But if you are putting the wrong number, it will crash the software. Okay, now let's continue. One important thing here, if you see in this one, sometimes memory allocation does not reserve. Imagine if you have full memory, your computer is full of memory. So this is rare to happen nowadays, but usually we say, okay, you reserve the memory, and when you reserve the memory and put pointer for this memory, you need to check if this memory is okay or not okay. If the malloc retain null pointer, in this case, it's not reserving. But if it's retain just normal pointer, in this case, it's reserving correctly. So how we can do checking? So we will do checking very simple. When we do malloc here, this is all the time. We put here the number of bytes we need to save. Here is the number of bytes. Number of bytes. Okay. So this is number of bytes to reserve. Reserve in the memory. Okay. So number of bytes reserved in the memory in this number, and then after that, I will check, does this one equal null or not? If this one equal null, that means there is out of memory. That means you are not reserving. There is no memory, okay? And retain. Retain means just don't do anything. Just go, leave, okay? So if this line is doing, if we put these lines in a function, in this case, the function will just exit. The function will shut down. Okay, the function just exit without doing anything. Or you can exit the software. Like, for example, you say, okay, I cannot reserve, for example, if this one is equal null, that means I cannot reserve storage for this string. I cannot reserve storage for this string. I will shut down the software. So exit equal 1 means shut down the software. Okay? So this is, or terminate the software. So we need to do this check all the time. All the time when we reserve dynamic memory, we need to check. We will be sure, do we reserve correctly the memory? Does the computer has enough memory to reserve for us this amount of memory, a number of bytes? If yes, then this one will never run. But if no, it will run and terminate the software. Okay, so here how we can do this one. Here is the example. So we will say here line, here is the string. And then I will say, okay, how long is your line? You will say, okay, give me the line. So how many characters you want in one line? And then I will do reservation. Then after the reservation, I will check, is malloc retain null here or just normal pointer? If it's retain normal pointer, this one will never run. But if it's retain null, in this case, line will equal null, then there is no enough memory. So you will exit, okay? Else, if this one will never run, that means everything is okay and I successfully reserve memory. In this case, I can read from the user the contents and save this contents to the line string, and then print this one. Okay, so this is how we can do this one. So the only thing here I want to say, you must check if malloc reserve correctly or malloc does not reserve memory. Okay. Okay, now for reserving memory, you can reserve memory using malloc, and here you will put the number of bytes, okay? The number of bytes here will be, for example, how many elements, this one usually, how many elements times the size of the element, okay? So imagine here, for example, TIP is data type. For example, this one is integer, okay? You want to reserve, for example, 10 integers, storage for 10 integer. You will say, okay, 10 times size of integer, okay, size of integer. If you want, you create a pointer of a float. For example, this one is a float, okay? So if you have a float here, in this case, you will say, I want to reserve 10 elements of type float, okay? So this is how you can reserve, okay, how to reserve this one. So this is general equation here, regardless what is the type of a float. Float here is general thing. TIP, sorry, here. TIP is just general thing, any data type, integer, float, double, whatever, okay? So if you have a pointer for double, you need to put here double. If you have a pointer for, so you want to reserve 10 elements of double, you will put here double, you will put here double. If you have 10 elements of, for example, long, in this case, you will put here long and you will put here long, okay? So this is the general overview. And this one will be exactly, when you do like this, you are like reserving memory, because this n is the number of elements. You want to reserve 10 elements of type float, 10 elements of type integer. So it seems like array. You are reserving array. Using malloc, you are reserving array. Okay, so here is another example of how to reserve array using memory allocation, so, or malloc. So you can reserve memory. For example, let's say here I have integer n, and then I want to make array of integers. So I want to dynamically, okay, dynamically reserve storage, okay, storage for array, okay? So I want for array of what? Of integers, okay? I want array of integer, but I don't know the size of how many elements in this array, but I run the software and then I ask the user, how many elements in this array? The user will say here, okay, number of elements, for example, 10. I have 10 elements. I want to reserve array of 10 elements. I tell him, okay, I will say it like this. I will say malloc 10, so n is 10 here, okay, and then size of integer. And this one will go to the pointer tab, okay? Pointer tab, here is it. It's a pointer to integer, okay? And I will check, does this whole things from here, does all things from here to here, this one, they mean tab, does tab equal null? If it's equal null, that means I did not succeed to reserve this memory. If not, so in this case, I shut down the software. But if it's not equal null, that means everything is okay. So this one will not run, okay? And then what I will do after that, I will ask the user some digits. This digit equal n, how many digits? For example, 10. I will ask a loop, and I will ask the user 10 times to put elements inside the this array, okay? So you say I will give the address of this pointer element I. So this you will say, okay, wait, tab is not array, tab is a pointer. Why you are using this one like array? Because this one is exactly same like I say pointer. I will say pointer or tab. I will say tab pointer plus I. I is the element 0, so tab element 0, so tab is the address plus 0. Plus it means the address of the first element. If I equal 1, that means tab plus 1. Tab plus 1 means the second element. So if you have array, so this is array, imagine this is array of 10 elements, okay? So element number 1, element number 2, element number 3, 4, 5, 6, 7, 8, 9, 10, okay? So this element here, so tab now, this tab here, because you reserve tab using malloc, okay? So malloc will reserve memory of 10 So 10 elements or 10 times integer size. Integer size is 4. That means we'll reserve 40 bytes. And it will create tab. Tab is pointing to the first element. Point to the address of the first element in the memory. Okay? So that element is element tab. So this second element here is tab plus 1. Okay? Third element is what? Is tab plus 2. Okay? This element is what? It's tab plus 3, and so on, until the last one is tab plus 9. Okay, so this is how these things are working. Now this tab, I can use it, so this tab like this. So this tab plus 1, I can do it like this. I say tab, even it's a pointer, tab 1. It's okay. This one and this one are okay. Same. This one, tab, and this one is 2. Okay, and so on. So here, don't be confused about this notation. So the pointer, we can, for the pointer, we can use matrix or arrays notation, or we can use the index notation. So you can remove, if you are confused about this one, you can just say, okay, delete this one, and you will just use tab plus I, no problem. Okay? So this is how this one, and this one will read from user multiple elements, and then after that I will print these elements. Okay, now after that, what is this free here? Free mean after you do all of things, just free the memory of tab. That means delete this one from the memory. So this is the free. You might ask, okay, why do we need this free? We need this free sometimes when we reserve some storage in the computer memory and then use it to do some calculation, and then we delete this memory from the or this storage from the memory, or this variable from memory. Why? Because we don't want to consume or keep this variable in the memory. We want to save the memory, so we will delete it. So this is the meaning of the free. How about if I don't call it free? It will be deleted automatic? No. So tab, if you want to delete this tab, you need to use the free. Okay? Okay, so let's see this software together. Okay. Here, let's go here to this one example. Okay, I will stop this example and we'll use the second example. Yeah, tab here is. Okay, so we can play with this one. So let's run this one. Okay, I will run this one and see you the line by line and just see the output here. So here's it. The first one, input the number of elements in this array. How many elements you want in this array? I will tell him I want 10 elements. Okay, so in this case, okay, he will reserve now for me memory of 10 elements. If you are confused about this one, no problem at all. So this one, if you are confused, just move this one to outside. Don't be confused about anything. So here we go. So you can put this one outside here, and then you will say, is tab equal null? Like this. Okay, so you will do like this. You say, is tab equal null? Okay, so this one, if tab equal null, do this kind of thing. So I will put semicolon here, and sorry, I forgot this one here. Okay, so here is it. Okay, so this is the same like the notation you see before. So tab equal null, or you can keep it as it is. Okay, so let me keep it as it is here. It's okay. So now, let's see, input number of elements, I say 10, and then I click enter. He reserved now for me 10 elements. And it seems succeed. Why succeed? Because he did not show me memory location error. He did not say for me that. That means everything is okay. My computer have enough memory and everything is fine. Then after that, he is waiting me now to insert 10 numbers. So I will say, okay, 1, 2, 3, 4. By the way, I can make space 5, 6, 7, 8. Okay, 8, 9. I think this is enough. Okay, so here is okay, 10 and 10. Okay, here we go. And here are the numbers. 1. So this is the second loop. Second loop will print all of those numbers. Okay, so I hope this one is clear for you. Okay, so this is how you can reserve dynamic memory. Next time, if you run the software, you can reserve more, less or more. So here is it. Next time, I decided, okay, I will save memory array of 5 elements. Here we get 5 elements. Okay, everything is fine. Here is the first element, second element, third element, fourth element, and fifth element. Click enter, and everything is work. Okay, so this is how you can reserve memory. Okay, so how to reserve an array of string, array of characters. Array of characters means string. Same idea, same idea. So you can say here, for example, I have a string 1, it's 40 characters. This is fixed, not dynamic, okay? So this is fixed array. And this one is a dynamic array. This one, I say, okay, create a pointer, this array, and I don't know the size of this array. And then I will ask the user, enter a string, okay? So he will insert for me a string for 40 characters, the first array. So for first array, so the fixed one. And then after that, I will say, reserve for me string 2, and this string 2 will be size of string 1 plus 1. So it will allocate for me same size like the fixed one, and then it will copy from string 1 to string 2, okay? And that's it. This is so you can do copying, or you just dynamically allocate an array of characters like this one using malloc, and then you will insert to this string. Okay, now one point I want to mention here. When you are, for example, having function, and in this function you are reserving some memory, and this memory is, for example, 10 elements, and each element is one integer. So you are reserving an array of 10 elements, okay? So here, for example, you will have an array of 10 elements, okay? Here, 1, 2, 3, 4, okay? Then after you, after you do some job here, for example, in this area, you do some job, okay? And then after you finish this job, this function will terminate. This function will just go back, and then it will go back to the main functions. So for example, imagine we have the situation of, you will have this situation. So for example, in the main function, you are calling fact, okay? This one, phyct, okay? You are calling phyct function. When you call phyct function, he will jump and execute this function, okay? And then after he executes this function, he will return back and continue the code inside the main function, right? So when we are doing that, what will happen to the memory allocated, or this 10 elements array? What will happen to this one? So the pointer here, when you terminate this memory, this pointer is goodbye. It will just disappear, delete it. But how about this memory allocated here? Does this one disappear? No. Unfortunately, no. So what I need to do to this one stay in the memory? That means, imagine I call this function 100 times. So if I call this function 100 times, I will reserve in the computer memory this array 100 times. So each time we reserve 40 bytes, because 10 times 4, 40 bytes, 100 times, that means you are reserving this one 4,000 bytes. So if you run this one 100 times, you will keep in the memory malloc. This one will stay in the memory, even if you shut down the function. That means the function is terminated and back to the main memory. Still, this malloc area will stay in the memory. So you might ask now, what is the solution for this problem? The solution is easy. After you, at the end of the function, before retain, we will do very simple step. We will say here, before this one line here, we say 3. We will say this function. We call this function 3p. Okay, so that's it. 3 this one. That means 3. Where is this pointer is pointing? So where is this pointer is pointing? Free this one. So what I mean by free, mean delete this one from the memory. So because we don't want it anymore, so just free, make it free. Okay, so this is the solution for this one. And this is what we saw here. You see here in the previous example, we use 3. So this free means we don't need this storage anymore for tab array, and then just free this one. So this is very important line to keep your memory not flooded by reserved memory, and we don't because this reserved memory will stay in the this reserved storage will stay in the memory, in your computer memory. So the only solution is to free. Okay. Okay, so another so here another important thing here. When you are reserving, you are calling some function and you are making a pointer, and then in this pointer you are reserving some storage for this pointer. This is a good way. The bad way is you create an array like this. You create an array, and then you are filling this one with some contents, okay? Because here you are using fixed array. Fixed array is a bad idea, especially if you don't know the size of the array. If you don't know how much the amount of data the user will insert inside this array. Does the user need 10 elements? Does the user need 1000 elements? Does the user need, the good way is to use the malloc, which is a dynamic memory allocation. Okay, so this is very important for allocating. Here is example about, just example. In this example, I have vector or array A and array B. And then I will pass the first array to a function add vector, and this one I will pass to a function, okay, another vector, and then I will give the size of these vectors. So 1, 2, 3, so the size is 3. Okay, and then I will add vector. What add vector will do? It will add 1 plus 4 equal 5, 2 plus 5 equals 7. So it will generate, this one will generate a new vector, and that vector will, this vector will include 5, 7, and this one 9. Okay, so this is a new vector. That vector will be RR vector. Okay, and then I will print this vector. Okay, using another function, print vector. So here I'm sending one array, two arrays. So the first array address, second array address. So this address of the first array, this is the address of the second array. So those will go to add vector 4. So here is it. The first address will go to this pointer. The second address will go to this pointer. And that means those two pointers are now pointing. So this pointer is now pointing to this one. And this pointer is now pointing to this one. Okay? Then after that, what I will do, I will say, okay, what is the size of those vectors? So this is a general question. So imagine first time you are passing vector of 3. Next time you pass vector of 5. Okay, and so on. So in this case, it will work. So I will reserve storage, and this is storage for a new vector. So this is RR, this is a new vector. And I say this vector is equal the size of these two vectors. Okay, this is n, the size of the vector. And if everything is okay, if R is a problem, there is a problem, terminate the software. But if no problem, in this case, start taking the value of the first element in the array and the second element in the, so the first element in the array, and then add them and then give them to this element of the vector. Okay? And increase AA and increase BB. That means go to the next element. So let me just show this one, because maybe some will feel confused about this one. So I will draw and show you how this one will work. Okay, so imagine I pass A and B. So A will be like this. Okay, here is it. A will be like this. And B will be like this. So A equal 1, 2, 3. And there is a pointer A. Okay, so here is the pointer A. And then there is a pointer B, which is this one. And this B is pointing to array. And this array is 4, 5, 6. Okay? Now, what I'm doing here, I'm saying the value of, I make a loop. And in this loop, I say from 0 to the size of n to n. N is a 3. So from 0 to n, that means 0, 1, 2. Okay? And then what you will do here, I say value of A, okay, the value of this pointer. So this is A. The star of A is mean the value inside, okay? The value inside of A plus the value of inside plus the value inside B, okay? The value inside B, okay, sorry here. The value inside B, those will go to where? Those will go to the value of R. Or they will go to the R, this one, okay? R0. R0 is the new vector. This is R. So R is pointing to here, R, and R has 3 elements. R, okay, this is R0, R1, and then R2, okay? Or this one is equal R plus 0, R plus 1, R plus 2. This is the address of this one, and this one are same, okay? So you will say this one and this one will be same, okay? This one, same. That means the value, so this one, R0 means the value inside this element. This one is the value inside this element, okay? And this one is the value inside this element, okay? So here I'm saying R0 is receiving the value of A and star B, or it's receiving the value of A0 plus B0, okay? Okay, this one and this one are exactly same, no problem. Okay, or you can mix. You say, okay, R0 is same like you're mixing. So array notation and pointer notation, no problem. But don't forget, in the next loop, you need to increase the pointer. Increase the pointer of A. So A now is pointing to this one. And B now is pointing to this one. And now, if I say star of B, that means I'm taking the value here. And the value, star A is the value here. And then give them to what? Give them to R1. Okay, R1. Next time, because I is increasing, next time A is increasing, B is increasing. That means A now is pointing to this one. And B is pointing to this one. And then R increased also. R became 2. So now R2, okay, R2, that means this one, equal A value of pointer A. The value of pointer A is this one. The value of pointer B is this one, okay? So this one will go to R2, and this one will be, so the result vector will return back, and this result vector will go here, okay? So now RR is pointing to the new one, this one, which is equal to this one will be equal to 5, and this one will equal to 7, and this one is equal to 9, okay? So this is how this one is working. Print vector. What is the print vector? I will tell him the size of the vector, and I will tell him print this vector. So what this one will do, just I will give the address of the vector, okay? The RR now is the vector. So now there is a pointer A is pointing to the vector RR, and then I will go loop, and this loop will print all elements of this vector. So here is it. I increase the vector pointer, and then every time I print the value of that pointer, So let me run this one together and see if this one is okay or not okay. So I will go here to the third example. Okay, here's the, no, this is the string. So we already done the string thing. I think it's example. Yeah, it's this one. Okay, so let's see this one together. Okay, so here's it. You will run, and let's see if the output is as we draw or not. Yes, 5, 6, 7, 9. 5, 7, 9, which we have 5, 7, 9. Okay, so here is this one. So if you don't like this notation, by the way, so here, how about if I say here R, this one RI, I will say this one just like this. I will say this one like this. Is it same results like this? Is it okay? Yes, it's okay, because you are increasing R pointer. Okay, I need to increase the R pointer. Here is it, R pointer. Okay, so I will do like this. So let me run this one and see if this one is okay. Okay, so let me just see what is the problem. Yeah, so here, if you see, I just forgot, I replace R, I say R plus plus, and I forgot to increase II. So II must be, to terminate this loop, I need to increase I. If I don't increase I, this loop will never terminate, okay? So this is why it's crashed. So here R plus plus must be, and then you increase R plus plus, that means this one, okay? So does this one work? Let's see. Yes, it gives you some garbage. Why this garbage here? Because now after you increasing R, so every time you increase R and then you go put the value of AA and BB to the R and increase R, and then after that you retain R, the last R. The last R is the last R. So here is the vector of R. So the first time R is pointing here. After the second, in the second loop, R is pointing to here. And then in the third loop, R is pointing to here. Okay. And then you retain R. When you retain R, that means you are retaining this address. You are retaining this address. When you retain this address, that means I say from this address print 3 elements. So it will print garbage from the memory outside here. So how to make this R go back and R point to here? So to make R reset the pointer. To reset this pointer, we need to go here, and then after this loop finish, I tell him, okay, now after you fill R every time, retain back the address of the pointer to the beginning of the vector. To the beginning of the vector mean R equal the old R, so the current R minus 3 locations, because it's jump 3 locations, okay? Or we can replace this one like this. We can say R 3 R minus equal 3. This one is same, okay? This one and that one is same, okay? So you can, this one and this one are same, okay? So you retain this one and you will run and you will see this is working fine, no problem. You see 579. Okay, so it's up to you to this notation, or you are using without this, all of this hustle, you will just use this way. Okay, so it's up to you, but you should understand how this pointer is working. Okay, now let's continue. Next is free. We already talked about free, and we said free to free the memory of the dynamic allocated memory. So you have to call free every time if you don't need this dynamically allocated memory. If you don't want it, just free this one from the memory. Okay, there is another type of same like malloc. There is one we call it colloc. Colloc is mean contiguous or continuous allocation. So this continuous, it's doing exactly the same like malloc. So it's reserving here, say how many elements you want, but now here we don't say times. You see this one, there is a comma here, no times. So you don't say 5 times size of integer. No, you say 5 elements, comma, and the size of each element. So it will reserve this one, and it's the same idea. So if you see in some code, this is why I'm mentioning this one here. Maybe in some code you will find some programmer use malloc, okay? And some people are using colloc or contiguous allocation, okay? It's continuous allocation. So any of them is working the same functionality. There is another one we call it realloc. Realloc means reallocate. Change the memory. So for example, at the beginning, I reserve memory for 5 elements, and each element size of integer. That means I reserve array of 5 elements, okay? In my and then later, I say, oh, no, I need now more storage. So no problem. You see this pointer, which allocate, this pointer is pointing to this memory malloc. I will tell him, okay, reallocate, and you give the same pointer and you change the size. So this is a new size, And in this case, what will happen? The old size will be reallocated and increase it. So before it was 5 times 4, which equal 20 bytes. But now when you say reallocate, you will give the pointer, the same pointer. And now the pointer will be 10 times integer. The 10 times 4 mean 40. So it will be 40 bytes. So this is the reallocate. Okay, relock. Okay, here is example, and it's very simple example here. You say enter number of elements, so you create a pointer for array, and then you can enter number of elements, and you are, imagine the number of elements is 5. Okay, so I would say call lock or malloc, it's okay, malloc, but in malloc you will make times here. In call lock you will say n, that means number of elements, comma, the size of each element. Okay, and now the array reserve 5 times 4, which equal 20 bytes. Then later you check here, everything is okay. Yes, everything is okay. If everything is okay, I will say memory successfully allocated, no problem. And then I will say get element of the array. So here is it. The element of the array will be, each element in the array will equal I plus 1. So that means elements of the array. So you reserve an array, and this array is PTR. And this element array has 5 elements. Okay, and the first element will be 0 plus 1, which equal 1, second element 2, third element 3, third element 4, fifth element 5. Okay, then later here I will do what? I will print the elements of the array. Okay, this is will print this one, 1 2 3 4 5, and then after that I say no, a new size now. I want n is equal 10. So I will say reallocate the same pointer, you see, the same PTR. I say reallocate. So it will reallocate, and now 10 elements. 3, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 elements. And now the PTR is pointing to 10 elements. And then after that, I fill these 10 elements by, for example, this one will be 6, 7, 8. This is from I equal 5 to I, so from element 5, so that means keep the first element, don't touch them. So the first element will be 1, 2, 3, 4, 5. This is the first element. And then the new element starting from I equal 5. From I equal 5, put the value 6, 7, 8, 9, 10. And then this one will print those elements. Then after you finish, free this memory. Okay, so we don't want it, so free it. Okay, so let's see this one together. If this one generates for me exactly what I explained. Okay, so let's see this one. Okay, run, and here is it, the same software. Okay, so same software, but just want to run and show you the output of this one. So here is it. The element of the array are 1, 2, 3, 4, 5. Okay, and then after that, reallocate a new memory. Okay, here is the reallocate a new memory, and it's 10. And then the new memory, the memory successfully reallocated. And then after that, the new elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is the output of this one. Okay, so that means this is about reallocate. So you can allocate some storage in the memory and save some data inside it. And then later you say, okay, I want to extend it. You can extend it, no problem. Okay. Now another thing about structures and pointers, because we are still talking about pointers. Can we create, before we study how to create pointers to integers. So I say, for example, integer star PTR. So this one is a pointer, and this pointer will point to some location in the memory, and that location will be integer value. Okay, so it's integer variable. So can we make a pointer, and that pointer not point to integer, it will point to structure? Can we do that? So for example, structure student. Okay, student is a structure, and I point to a structure, and inside this structure will be student name, and the student GPA, and then student age. Can we do that? Yes, we can do that. So we can make a pointer, and that pointer will point to, what is the data type now? The data type is point structure. What is the point structure? Point structure is some point structure, okay? Maybe the point structure will be something like this one. Struct, okay, struct, point, and open, close, and it has integer x, and it has integer y. Okay, so inside it. Okay, so this is the structure. Okay, so I can create a pointer, and this pointer is pointing to structure. Okay, so in this case, for example, here's an example. I say create some variable of a structure. This is variable of a structure. Okay, and then I create pointer to a structure. Pointer to a structure of point. So then I say, okay, the address of this normal variable of structure will go to pp, or the pointer of the structure point. Okay. Now, if you would like to, if you create a pointer to a structure, how you can access values of this structure? You will use star pp.x or star pp.y. Okay. So if just I want to remind you, for example, if we have a structure pointer origin, in this case we will say origin dot x. Okay, this is how to print the value of x value inside origin, and to print the value of y of inside the origin, we say origin dot y. Okay, like this, to print the value of origin, the y value inside this variable origin. Okay, now if you have a pointer, and this pointer pp, and this pp pointer is pointing to this origin, how to print the value x? To print the value x, we will say like this, star pp, and then star pp dot x. So this one is exactly the value of origin.x. So if origin of x is equal 7, this one will equal 7. Okay, and then how about this one? How we can print the value of origin.y? You will say star pp.y. Okay, so this is how you can access the values inside the structure using pointer. Okay, another way is to use arrow notation. So this arrow notation, so you will say pp, and then you will use arrow notation like this. So you will use star p dot x, or so okay, so let's see here. I say star pp dot x. This one will give you the value of x inside some structure using the pointer pp. Or this one is exactly same like pp, and then you will say x. It's up to you. Use any of this notation. So you can make arrow, or you can make x. How to do the arrow? This is just the minus symbol with the greater than symbol together. We'll make arrow. Okay. So this is how you can do this one. Here is an example. So here's an example about this one. So this example, just I think by example it will be more clear for you. So I have a person here. This person has age, weight, name. Okay. So this is a structure. And then I design here structure pointer. This is the PTR. This is a pointer to a person. Okay, that's good. And then after that, I have I and N. This is okay. And then I say, enter the number of person. How many person do you want? I'm going to tell, okay, I want, for example, 10 person. So N is equal, or N is 2 person. I want 2 person. So I reserve memory, and the memory is, for example, N will be equal to 2 times size of the person. Size of the person is how much? This one 4 bytes, and this one is 4 bytes, and this one is 30. So the total is this one 38. So that means 2 times 38. This one is the size of this pointer. Okay, this is a pointer, and this pointer is pointing to 2 structure. It's array. This means PTR here is array. This array of 2 person. Array of 2 person. Okay. So there will be array of 2 person. The first person has age and has weight and has name. And the second one has age and has weight and has name. Okay, so there are 2 person, and this one is point to using PTR. Okay, because PTR is pointing to a person structure. Okay, so PTR1, PTR1 is the PTR0 is this element. PTR1 is this person, this structure person. Or I say PTR plus 0 is this person, and PTR plus 1 is this person. Okay, so what I do here, I will say, okay, enter the first name and age respectively. So I will read from the user, scan one string, and this string will go to the PTR0, here is it, PTR0, and from PTR0 go to the name. So at the first string, scan from the keyboard string, and this keyboard string will go to the first PTR plus 0, that means this guy, PTR plus 0, and name, okay, name, it will go to the name, okay? And then after that, scan some digit, and this digit will go to where? This digit will go to the PT address, PTR plus 1, sorry, 0, plus 0, and age, okay, age. Okay, so in this case, it will read one string, one digit, one string, one digit, and we'll do this one 2 times. Why 2 times? Because n is equal to here in my example. Okay, then after that, how to display this one? It's same. I will make a loop from 0 to 2, and then I will say the name of the first person, name of the first person is equal PTR plus I, that means PTR plus 0, name. And then this one, PTR plus 0, age. Okay, so this is how this one is working. Let me play with this one with you in the Eclipse. So let's here, we go to Eclipse. Okay, and I think it's this one. Okay, so here we go. Here. Okay, so here I have a person, and then a person, memory allocation of person, and this one will go to PTR. So I will put 2 person for this one, and then the first person will go PTR I. This is the name, okay. And the second one is a digit. So this one is a digit, okay. This one just a string, and because in the string we don't put address. In the number we put address, okay. And then after that I print the name, and then I print the age. So I will run this one same like what I explained to you, and then I will play with this example. So let's see here. So here I have enter the number of person. I will just 2 person here. Enter the first and a name and age. I will say here Tam, and then space, and then I will say 20. Okay, so here is it. So let me just put it like this. Okay, 20, and then click enter, and it will ask the second person first name. I will say Kim, and then for example 22, and then click enter. When I click enter, it will tell me, display for me, this is the loop here. It will display information. We say Tam age 20, and then Kim age 22. Okay, so I will do the same example, but now I will play with this one. So here I say PTR plus I. So is it possible to replace this one, change this one to another way? So like say this one is a star and this one is dot. Is it okay? Yes, it's okay. And how about this one is a star and this one is dot? Okay, so what is the problem here? Okay, so this is a pointer. Must be like this. So you will have, because as you see in the presentation file here in the okay, here we said if you want to use the notation of dot, don't forget about this one and this one here. Okay, those are important. So let's go back to here. I will say okay, I will put this one and this one, and since I'm doing increasing the pointer every time, in this case I need to put this quotation here to tell you, okay, increase the pointer first, then after you increase the pointer address, just bring the value from the name, okay, the name or value. So this one, and then here let's do this one same, and then this one will be the notation of, this one is the notation of the pointer, and let's see if this one is working fine. Okay, here we go. So this one 2 person, and then there is Tam space 22, and then Kim, and then 20, and then run. Everything is working fine. Okay, so this is how this one is working. So you can use this notation, or you just back to the previous notation, which is more convenient here. So you will just increase the increase this one. Also, you can even use the array notations. So you can say here, okay, you can use here I. Okay, so you will have here a pointer, and then after that you will this one you will have this one, the array matrix array. So this notation is also okay. You can use this notation because this one is a structure. Okay, this is a structure, and then this structure, from this structure go to name. It's okay. Yeah, I know there are many variation here. You might wonder why I'm explaining for you this variation, because this one will help you to later if you would like to write code. This is more flexibility. So it's up to you. If you want to focus on one, it's okay. But this kind of flexibility will let you easy read other people code, and at the same time find any convenient way you like it to access the pointer, use pointer to the structure. So this is just kind of flexibility. It's up to you to use any way you want. Okay. Okay, now another thing is, so this is, I already explained. Now there is the last topic for this lecture is pointer to pointer. Pointer to pointer. So that means there is a pointer, and that pointer point to, as if things are easy and we want to make it a little bit complicated. It's already complicated, but here is it. So we want to see here pointer, and this pointer is pointing to a pointer. So maybe, I know, maybe you are asking now, why we need this kind of things? But I will explain this one. But for now, just want to tell you, there is this notation. Maybe you will see this kind of thing. This is a pointer to a pointer. So here is it, for example, variable 3000. And then I give PTR now is pointing to the variable. Okay, how? Look here. So address of var is good. So PTR is pointing to var. And then here I say, create a star PPTR, and this one, the address of this variable or this pointer to the pointer, the address of this one is pointing to this one. Okay, so in this case you will have pointer PPTR is pointing to another pointer, and this pointer is pointing to another variable. Okay, so this is good. Now the answer is, why do we need this one? So we need this one sometimes you will have function. Imagine this scenario. You have a function, and this function receive a pointer. When it receive a pointer, in this case, when it receive address, that address area, you will give it the value 5. So if you pass here, for example, get value of 5, so you will pass x. X has no value. When you pass x here, the address of x will go here. Now the address of x go here, and then you give value for the variable x. So now x became equal 5 after this one, after you call this one. Now the other way is this function. This function here, you will pass here address of a pointer, and then this pointer will point to some location in the memory. Okay, so I will say here, for example, star P is a pointer to a pointer. Okay, and I tell you here, this star to star pointer, the star pointer, that means where is this one is pointing, the star pointing, so there is a star P, and this star P is pointing to star P, okay, to this pointer, and the star P is pointing to somewhere. Okay, I will say here, star P is a pointer to some location in the memory. 1204. Okay, so this now the star P is pointing to this one. So how I can use this one? I will say create some pointer. I will create some pointer here, and then I will pass the address of that pointer. Okay, when I pass the address of that pointer, this one, what I want to say here, I want to fill this area of this one. I want to reserve some storage in the memory, and this storage, this pointer will point to this storage. So what I will do, I will pass the address of this pointer, and the address of this pointer will come here. And then from that one, that means this is the address of this pointer, I will say reserve some memory. When I reserve some memory, now this pointer now is pointing to this memory. Okay, is pointing to this memory. So we are creating pointer and then call function. This function will make this pointer initialize this area, reserve some area in the memory, point to some area in the memory. Okay, so we can use the function with double pointer to initialize. This is what I want to say, and be careful for this sentence. I want to use this function with double pointer here to initialize pointer. To initialize pointer. So the pointer now initialize. When I put this one here, this pointer initialize to point to a memory of 1024 bytes. Okay, so I initialize this pointer. This pointer was not initialized. This pointer point to nothing. But after I call this function, now the pointer is pointing to some location in the memory. Okay, so we can use the double pointer to initialize the pointer. Double pointer to initialize pointer. So this is just one example of the double pointer. Okay, there is another example of the double pointer which I will not explain because it takes some long time, is that using convert the two-dimension array, maybe if some of you are interested, they can go and study this one by themselves. The two-dimension array is double pointer array, single array. Okay, double pointer, single array. Okay, how and why and where and when, this is, you can study you by yourself if you are interested. So you can say how to convert two-dimension array to a single pointer array. So in this case, you will find some people talk about this example of about double pointer. So again, for our example here, we just take one case of the double pointer is to initialize a pointer. Okay. So yeah, today we talk about dynamic memory allocation. We talk about malloc. So malloc to initialize memory, and also we talk about calloc, and this calloc is very similar to malloc. And also we talk about reloc. Okay, a reloc to reallocate, and also we talk about free. Free is to free the memory or the reserved storage. We use reserve using these two. Using these three functions. So this one to free the memory. Okay. Also, we talk today about how the this reserved memory using malloc, calloc, and reloc will not be deleted from memory until you are using free. So you must use free to free this storage, or it will stay in for lifetime of the software. It will stay in the memory. Okay. Also, we talk about today about pointer to a structure, how to create a pointer and that pointer point to structure. And also we talk about double pointer or pointer to pointer. So that's it for this lecture. So yeah, this is also the end of this class. So I would like to thank you all for having me in this class. As a closure for this course, I wish you all get good benefits or get some nice principles about how to program. I know some of you are from different background. Maybe some parts of the course was hard for you, some parts were easy for you. My goal was to cover as much as possible of the principles in programming. And as I told you before, those principles are applied in any programming language. So whatever you learned here, you can apply for Java, you can apply for web design programming languages, you can apply this one for any type of programming language. And those principles, if you are interested in programming, even if you are from different domain, not computer science, in this case, maybe you can use your skill in this programming to create softwares in your domain. For example, if you are from biology domain, you can create software for biology. If you are from chemistry, you can create softwares for chemistry. If you are from any domain, those skills of programming could help you if you are interested, and you can extend them to create a nice, beautiful software in your domain. I hope this course was achieving its goal, and you have learned how to program to create some simple softwares, and you just put your first steps or put your hands on the first steps or on the programming skills. And if you would like to extend these skills more in the future, you can go ahead and do this one by yourself without any help, because you already have some good knowledge about programming from this course. So I would like to thank you for having me in this course, and I hope you enjoyed this course with me and had a pleasant time listening to the course and practice the lecture exercises and assignments which we have choose carefully to let you enjoy programming. That's it. Thank you, and hopefully to see you in the future in any other course related to computer science. Thank you.